Hi everyone, and welcome to the second Women on Stage conference. Thank you for being here. I'm super excited to be here today, and I'm thrilled to have all of you joining us. My name is Moran Weber, and I'm the CEO and founder of Women on Stage. And for those of you who don't know us, Women on Stage is a global community platform to showcase, book, and train women tech speakers for any event, conference, meetup, or webinar. The platform was launched in May 2020 and achieved overnight viral success, already making it one of the biggest databases in the world for women tech speakers. Our mission statement is to amplify women's voices and to create a world where women make at least 50% of tech speakers, because we believe that if you can see it, you can be it. Apart from the platform, we also launched the second course of the Women on Stage Academy, which is a full-blown course to train the next generation of technical women on stages. And for the next 3 days, we are having our ending conference where each of our 30 graduates will present their talks after they've been building and polishing their presentations throughout the course for the past 3 months after getting personal, tailored feedback from world-class speakers and mentors. Our speakers are working in senior positions at some of the best-known tech companies in the world. On top of that, we also have 3 keynote speakers opening each day. Our speakers are going to present highly technical, professional sessions covering data, machine learning, NLP, backend, cloud and big data, frontend, React, mobile native development, security, software engineering methodologies, quality assurance, architecture, and many more. Before we start, I'd like to thank all of the people and the companies who made this course and this conference possible. Thanks to all of our awesome sponsors who actively choose to promote diversity as part of their mission. We truly couldn't have done this without you. Be sure to check our job board with lots of wonderful opportunities from our sponsors. Thanks to Event Handler Productions for producing our conference and to the team organizing the event. Special thanks to all of the course instructors, which are world-class speakers and true legends. And last but not least, to our talented, brilliant, and dedicated mentors who accompanied our students throughout the course. Alright, so one last thing before we start. You're welcome to ask questions on our YouTube channel. The sessions are pre-recorded, so the speakers are going to be available during their talks to answer all of your questions live. We love to hear your thoughts. Ready? So here we go.
When I first started my Army service, I was drafted to pilot course. And I remember at one of the Saturdays sitting outside of the tents with a good friend of mine. And he told me, Rotem, you're so lucky to be born in those days. And I looked at him quite surprised, didn't understand really what he was saying. He told me 100 or 200 years ago, women couldn't vote, women couldn't get education, couldn't have their own money. And look, today, women could be pilots. How amazing is that? And I remember myself sitting there and thinking, wow, I am really lucky. But it took a few years for me to grow up and to understand that the world is still not as equal as I thought it would. And by looking at the parliament or women in boards or the salary differences, we can see we still have quite a lot of way to go through. But today, I don't want to talk about those glass ceilings. I want to talk about the glass ceilings that we as women put to ourselves. So nice to meet you, and I'm happy to be here today. My name is Rotem Shavit, and I'm the CEO of Talkmasters, School for Lectures and Public Speaking. And I remember when I first started giving courses in public speaking, I remember women doctors who had really hard time saying that they're doctors. And that most of the time when I see women in our courses need to speak, they open up, you know how? Right, apologizing. And also many times when I ask someone to volunteer to practice speaking, most of the times men would be the first to stand up and talk. So I decided to do this lecture and to talk to you today about how we can start talking better. So on the first part, I want to break some myth and give you some interesting information to think about. And on the second part, I want to talk about how to do it better. If you open up the book 100 Best Speeches of the History, you probably wouldn't see many women there. So I brought to you today 3 very interesting and very successful women, so to listen to their speeches and to see what we can learn in order to talk better in our lives. When I ask in my lectures, what's the difference between men who speak and women who speak? Most of the times, the first answer people answer, and especially women, is that women are drilling. And I remember a few years ago opening up a news website and reading this article about this British scientist, the author of the bestseller book, The Feminine Brain, that said in her research, she found that women speak 20,000 words a day, while men only speak 7,000 words a day. And I remember thinking, wow, that's interesting. Women speak 3 times as much as men. Maybe it's because we need to explain men everything 3 times. Makes sense, right? But actually, this research was refuted. And the truth is that women and men both speak 16,000 words a day. And the difference they found in this research was only in different professions. There are professions that speak more words than other professions, but both men and women speak the same amount of words, so just so you know. But I do think we sometimes drill in our own brain. Rashema Saunjani, the founder of Girls Who Code, in her TED Talk, she tells a really interesting story. She said that her friend, who is a professor in the Columbia University and teaches the course of Intro to Java, told her that we noticed something really strange. He noticed that when male students come to him with a problem, they usually said, "Professor, there's something wrong with my code." Whereas female students come to him, they usually say, "Professor, there's something wrong with me." And there's other researchers that show that when men succeed, they usually think to themselves, "Wow, I'm so talented, I'm great, I'm smart, I rock." Where they fail, men would usually think, well, the test was too hard, the professor didn't like me, I didn't study with the right friend, and something in the environment outside of them was the reason for the failure. While as women, we usually do the opposite thing. When we succeed, we usually think it's something else. I learned with the right friend that helped me, the teacher liked me, there were no other competitor for this job. While we fail, we usually think, well, I'm not smart, I'm not talented, I'm stupid. And it's not something we were born with. It's something that many years in our society taught us to think. And I tell you this today in order for you to start thinking about that the next time you succeed or fail. Start celebrating our success and thinking again about our failure. Is it an opportunity to learn and to grow? Or in other words, let's start to change our story. Maybe we could put a question mark on the times that we think we did it bad, or we can try to do things we're not used to do and get better. Many times we tell ourselves there are things we're not good at. We can't do it at all. And I want to tell you a short story about a time I decided to change my story. For many years, I've been telling myself I'm not funny. I'm the eldest at my family. And as eldest, I'm the responsible one. I'm the one that takes the entire world on my shoulder. And I have two young sisters who are very funny. Every family gathering, they're the one that do the laughs. And when I became a lecturer a few years ago, started to give lectures and talks, I realized that humor is a very important tool for my toolbox. And using humor is very important in order to grab my audience attention. But I kept on telling myself, what can I do? I'm not funny. I wasn't born funny. So one day I decided to change this story that I've been telling myself for years. I went to learn how to stand up. I went to this stand-up club, and for 10 weeks I came there every week to stand on the stage for 5 minutes and to do a stand-up comedy. And I can tell you it was the frightest stage I've ever talked in front of. And I've been talking to thousands of people in much bigger stages before, but there in this small club in front of 15 or 20 people who we gathered from the street begging them to come to listen to us, it was the most frightening stage I have ever stood on. And I learned so much from this experience. I learned that sometimes when we tell ourselves again and again, I can't do that, or I'm not good at that, we start to act that way. And when we start putting this question mark and thinking, maybe I could get better, then that's the beginning to really getting better in that. I want to give you a few other researches. One is there's only 15% of speakers in biology conferences who were examining this research were women. But I think what's more interesting about this research, and of course in other science fields the situation is quite the same. What's interesting, or even another thing to look at on this research, is that it wasn't that women wasn't invited to talk on those conferences. They were, but many of them refused. Only 26% of the men said no and refused to come and speak, while 50% of the women that were invited to those conferences said no. And it doesn't matter if the reason is excellent. If there's not enough budget, or there's too much invitation, or something in the workplace, could be excellent reason to say no. But when we say no, when we refuse to go on stage and speak and to talk on those conferences, we lose many opportunities. We don't get acknowledged. We don't get the exposure we could. We don't get the opportunities that we could win in our career. And another important thing to think about is that we never know who is listening to us. We can never know who is sitting in the audience and what door it might open to us. When we go on stage, maybe in the audience there's our next business partner, or an investor that could invest in our project, or maybe even our next date. In the audience, maybe there's a great opportunity, and when we don't go on stage, we don't know what we miss. When I was in the army, at the beginning of my army, I told you I've been in pilot course, but there was a slight problem. And the problem is that I have this horrible fear of height. And I realized it's a very big problem a few months into the course when they told us we're going to do a parachute jump. So they took us to this place, and before the parachute jump, there was a full week of practicing toward this jump. And I remember one morning, the instructor came to us and said, guys, today we're going to do the Eichmann. What is the Eichmann, you probably think? And Eichmann is the tower, about 15-meter high. You need to climb on, buckle up, and jump. But it's not enough. I have this horrible fear of height. They called it by that horrible name. So I started climbing up this ladder, and every single step of the ladder that I climbed, I remember myself shivering and shaking and barely breathing. And I remember my heart pounding stronger and stronger, every step of the ladder I was getting up. And I got to this end of this tower, and I looked down, and I saw this height, and I was so terrified. Look, I have evidence for that. If you didn't believe me, I was really terrified. And I was thinking to myself, well, Rotem, why are you doing this to yourself? And I was looking down there, seeing some other people looking to me in this look, you know, maybe you experienced this look of, why are you doing such a big deal? Come on, jump already. What would you do? Would you jump? Well, at that moment, I did the only thing I felt I could do. I closed my eyes really, really strong and jumped. If you can't see, I even zoom in. I closed my eyes so hard, I think they got to the brain. But I'm showing you these hard to watch photos because a few days after those photos were taken, I actually jumped off a plane, or maybe pushed, I don't know. But I did the thing I couldn't believe I could do. And I remember, even before getting to the ground, I got off the plane and I saw this beautiful scenery around me. And I thought to myself, how could it be? How could it be for this whole week for me to be so afraid, so scared of this moment? And now that it's happened, it's so unbelievably amazing. I felt awesome. And I didn't understand how could it be that I was so afraid of this thing. It got me to think really hard about fears. I went to study psychology in my BA because I was so into fears. What are fears? Every one of us have fears. There's no single human being that doesn't have fears, right? A fear is just the alarm mechanism our body has. When we used to go out in the savannah thousands of years ago, see this lion, instead of going petting it, our body tells us, don't do it. It's something, it's danger, fight, flight, you know all of that. But today, most of our fears are not life-threatening. Most of our fears today are stories. Really good stories that we tell ourselves. And then we live by them because we don't want to find out that we were wrong, right? Especially if we're Israelis. So we prevent ourselves from doing a lot of things because we give in to our fears. And I decided I'm going to change my relationship with fears. I realized that most of the times we don't have fears, right? When we go to work, when we're in our day-to-day life, we start feeling those butterflies when we have an opportunity to grow. I started to see that every time I'm doing something that takes me out of my comfort zone, that challenge me, that enables me to grow, that's the time I start to feel afraid. Like this talk today in English and recorded, something I don't do every day. And I was very afraid before starting to talk to you today. But I know that when I'm feeling those emotions, it means I have the opportunity to grow, to do something new, to do something better. And maybe because of that, I got to deal every day with number one fear in the world. You know probably what it is, right? It's stage fright. Fear of public speaking. They say about 75% of the people have fear of public speaking. And I say 25% of the people are lying. Because we don't have to have the audience of 1,000 people in order to feel this fear. It sometimes can be even one person, a very important person, an interview, a boss, something important in our life that can make us feel that way. And I remember in this picture, it's me in front of 15,000 people. That was very frightening. But every time I'm doing such a thing and I'm still afraid, I know it's an opportunity to grow. So when I get an opportunity, instead of saying no, first of all, I say yes. I close up my eyes and jump. And I want to invite you to do the same. Close up your eyes and say yes. Just jump. And later on, see how we can do it. And I'll give you a few interesting tips in order to do it in the best way. But the first step is to say yes. And two questions I ask myself to help me when I feel this fear, the first time is, what is the worst case scenario? What is the most horrible thing that could happen if I'll do it? Maybe I won't get the job, maybe I won't get accepted, maybe someone wouldn't like what I said. But usually when I start to think about what's the worst case scenario, it gets a bit smaller than the big story I have in my head. And the second question I ask myself is, what could I miss out? And this is even a more important question. What could I miss out if I skip this opportunity? What interesting opportunities, what new doors could be opened up to me if I'll do it, if I'll try? So you could try using those two questions, and I hope it will help you too as much as it helps me. In the second part of this lecture, I want to welcome 3 amazing women. As I told you, if you open up the book, The 100 Greatest Speeches in History, you probably wouldn't find too many speeches given by women. So today I want us to watch short parts of 3 short speeches, and to see what we could also learn from those women in order to speak better. After we say yes, after we start speaking as much as possible, and it doesn't have to be only in conferences, it could be in meetings and small opportunities in order to get better. So our first guest for today is Hillary Clinton. Hillary, in the Texas conference, the interview asked her quite a hard question. He asked her, what is the most difficult test you had in your life? Let's see what she answered.
Well, I think everybody here knows I've lived through some crises and some challenging moments in my life, and I am grateful for the support and the prayers of countless Americans. But people often ask me, how do you do it?
So what can we learn from Hillary? First of all, not every question we've been asked in an interview we must exactly answer. She uses self-humor. Instead of starting to talk about Monica Lewinsky and all the fuss and all the things about that would make it a horrible interview, she uses self-humor by saying, well, you know, I've been through some crisis in my life. The audience laughs and everyone feels good. But then she takes this opportunity to talk and gives the messages she wants to talk about. She says something very interesting. She's saying there's countless Americans praying for me. And also she's saying, many people ask me, how do you do it? What do we understand by those 2 sentences? That there's many people that think she's great. She could be a great president. She's awesome. She's talented. But if she would come and say, I'm great, I could be a great president, we wouldn't really like to hear that. But when we hear that other people say it, it becomes much more objective. We believe her. It's like going in a website and reading the reviews of other people. They seem so much more objective than reading something that the owner of the website would write. That's why we want to read reviews. So saying, other people tell me, or someone told me the project I did was so great, or saying people ask me about this and that, is a much better way, much modest way. And instead of bragging and praising ourselves, we give other people to say things about us. Another way to do it is talk about the facts. Instead about talking about our qualities, talk about the facts. Talk about the projects we've been through, we've done, the volunteering we did, the diploma or the achievements as facts, as how many people, what we did, what was the consequences. And that helps us to talk about ourselves and to let people know how good we are, but not by bragging, but rather in a much more modest way. Or as Golda Meir, Golda Meir once said, don't be modest, you're not that great. And so if she said so, we must start talking about ourselves, but doing it in a modest way. The last one I want you to hear today is Malala Yousafzai. Malala Yousafzai is the youngest one ever to receive a Nobel Peace Prize for talking about human rights, women's rights, and the women's right for education. So let's see what she talked about in what her small part of her speech in the UN convention.
I had two options. One was to remain silent and wait to be killed. And the second was to speak up and then be killed. I chose the second one. I decided to speak up.
So what can we learn from Malala? And she's only 16 in this speech. First of all, the use of pause. Many of us, when we try to talk and we need to think about what we want to say and we didn't practice enough usually, or we just need to take some time to think, we use filler words. Instead, trying to take a pause. The filler words take the attention to decrease the attention of the audience, and the pause increase the attention of the audience, makes our sentences stronger, more dramatic. So try, instead of giving a pause. Another thing that she does very well is repetition of the important message. Try to repeat a few times the most important sentence, the most important words, the most important messages you want the audience to remember. If you repeat it a few times in your talk or in your presentation, you'll give a better chances that they will remember it and take it with them. Another thing is, of course, she did prepare a lot for this speech. It wasn't something she made up on the spot, as you can probably hear. And preparation for our talks, for our presentation, is one of the most important things we should do, especially if it's an important occasion. Or as they say, fail to prepare or prepare to fail. Try to prepare as much as possible. Say yes for the opportunity and then go and prepare again and again. The outcomes would be much better and your fears would be much smaller. And the last thing she does is she's so authentic. It's something we can't fake. She really speaks about something she believes in. Sometimes people ask me what to do with the hands, what to do with the eyes. And I say, talk about something you believe in. Talk about something that excites you. When we talk about that, all our body language and everything we say with the spark in the eye just go out to the audience and becomes so authentic. Or as Maya Angelou once said, and with that I want to finish up today, people will forget what you said. People would forget what you did, but people will never forget how you made them feel. So say yes. Close your eyes and jump if you need to, but say yes. Start speaking up as much as possible and prepare and talk from your heart. Thank you very much.
Hi, I'm Karen Corsia from Taboola, and over the next 15 minutes, I will talk about big data that derive big business. In my presentation, you will get a glimpse into our main data pipeline and how we modified it in order to turn a user click into business insight in less than 5 seconds. But mainly, you will hear about a fascinating project I led that took us, the developers, beyond our traditional engineering environment. Taboola. You have seen us before. While you're reading an article on a website or on your mobile phone, we are working hard in order to discover what will be your moment of next. What is the thing that you may like to read or watch in your next free moment? We call it a recommendation, and we are a recommendation system. Our customers are both the publishers, the website where you can see our feed, and the advertisers who supply us the sponsored content. Our discovery platform, which provides these recommendations, is the world's largest content discovery platform. Take a look at these numbers. This is a true definition of big data and massive scale. Well, last summer during COVID-19, when we all worked from home, and I don't know about you, but I had children running around my computer, sitting on me, and sometimes sitting under me. And in this most unusual and unexpected time, we were approached with an unusual request from our business department. They told us about an unusual customers that are both publishers and advertisers. And they use technology to identify opportunity in the markets where they can buy traffic into their website, buy ads, and leverage them to create profit. Similar to the stock exchange, but on ads. And our business department find out that there is a big potential for revenue growth with these customers. So they ask us, the R&D, yes, they ask the R&D to talk with these customers, to talk with their R&D team, and to find out what they need. So we took the top 5 customers and we asked them one question. What do you need in order to increase your spend in Taboola? And we got a surprising answer. They need data, real-time revenue data. Our customers told us that they are using machine learning and models for prediction in order to discover which campaign bring good results, in order to find new trends in the market, and in order to tune their spend. And before this project, the input to those systems was the billing reports that we provide them. But the billing reports contain built-in delay. They must be accurate, they must contain the complete data, and they required complex calculation. Okay, so all these great automatic systems using data that is not fresh enough. We find out that our customers build the conservative predictions. They limit their spend in Taboola in order to fence off predictions errors. They need data in real time. They want to know how much they are going to earn on a click when the click happened, and not in delay. And another interesting thing, the billing reports contains aggregated data, but the customer needs as input user-level data. They want to know the revenue on single click, on single video. They don't need the aggregation. If they will know how much they are going to earn on single click and close to the time the click happened, they will be able to build a more accurate predictions. They will have confidence in their predictions, and that will cause them to increase their spend. So real-time revenue data in user level will drive revenue growth for them, but also for us. And why did the business people reach out to me? Because I'm an expert in the world of big data and massive scale. I am data platform software team lead in the infrastructure engineering group. And in our group, we are the kings of big data. Okay, so we went back to the business and informed them that we know what the customer needs. And they said, great, so when can you deliver it? And we thought that we know how to negotiate. So we asked them back, when do you need it? And the answer was, yesterday. It was a few months before the elections in US. And the elections are one of the most successful times for campaigns. So in order to be ready on time, we need that our new real-time data pipeline will be integrated in the customer systems before the elections. Challenge accepted, because being attentive to the customer needs is one of our core business value. And because we have confidence in our infrastructure, in our data infrastructure, and we know that we can do it. But we have several challenges. The technical challenge. 500 million active users per day is a lot of data and a lot of click. And we need to calculate and deliver revenue data in real time. And another important challenge, the collaboration challenge. This is Corona time. And we knew that in order to be ready, we need our customer with us. We need their dedication in this project. We need their collaboration. Okay, about the technical challenge. I will provide you now a glimpse into our main data pipeline, but it will demonstrate the challenge of reporting revenue data in real time. Let's zoom in. When a user enters to a website of one of our publishers, a client application on the website will send us a recommendation request. This recommendation request will reach one of our front-end servers. We have thousands front-end servers spread across 7 data centers around the world. One of the front-end servers will collect all the data about the user, the article he read, about geo, country, platform, browser, and much more data, and will build a response recommendation list, a personalized recommendation list. The client application will put those recommendations on the website. And from now on, every click the user will perform, every video he will watch, we will know about it. We will get about it user notification into one of our event logger servers. But it is not so simple. A user journey on a publisher website may contain several requests, several responses, and many user notifications. And they may reach different servers on different time. But all the data will be collected to Kafka cluster on the local data center. And this Kafka cluster is the beginning of the downstream. This is the beginning of the data pipeline. In Kafka, we have many topics. We have topic for the recommendation requests and responses. We have topic for the user notifications, topic for variables for debug, and many other topics. Kafka cluster from all the data centers mirror to one Kafka cluster, to one massive Kafka cluster here in Israel. And now a Spark component called Page Generator will summarize the user journey on the publisher website. It will collect all the data from all the topics and rearrange the data and save it into HDFS as Parquet file. And now the data is ready and we can start using it. And we are using it for reporting, we are using it for analysis, for machine learning and deep learning. And all these actions are taken in order to build next time the best personalized recommendation list. Okay, really, it's only a glimpse. And to really describe all the data pipeline, I will need another full session. But you can see the challenge of reporting revenue data in a data pipeline that carries trillions of entry data points every day. And about the real-time data pipeline. So we took this impressive data pipeline, we broke it, expanded it, and created a new one. I will zoom in now. The new data pipeline, the real-time data pipeline, starts where all the data mirror to Kafka cluster here in Israel. And now we build a new component. We call it Kafka Consumer for filtering and partitioning the data. This Kafka Consumer will consume from Kafka only the user events topic, and only events that contains revenue, only charge events, and only events that related to publishers that opt in into our new real-time data pipeline. We are turning big data into small data, and that enables us to report the revenue data in real time. It also enables us to support in the natural growth that we have in the data over the time. And now that we filter the data, we are using Kafka again. We create a new topic. We call it real-time revenue topic. And in this topic, we are partitioning the data. We create partition per customer. And for each customer, we write the revenue data to its partition. Partitioning the data enables us two main functionalities. Security, data revenue of one customer won't mix up with data revenue of another customer, and flexibility. If we will need to replay the data from the beginning or from a specific offset, we will be able to do it for one customer without influence the others. And now that we have the data in the new topic, we only need to deliver it. So we consume the data, and per customer, per partition, we deliver the data to a server on the customer side. And again, it's only a glimpse, and I'm here after this session to answer to all your questions and provide you more information. But let's continue. The best part is that our infrastructure is so generic and so modular, so in order to build the real-time data pipeline, we didn't need to do a revolution and write a lot of code. It was easy. And about the collaboration challenge, we overcome it as well. We let our customer become our design partner. We didn't build the product and then convince them to use it. By asking them what they need and meeting their requirements, they want to use it. They are waiting for it. But again, it is Corona time, and we knew that we want to build a direct communication with our customers. Our solution for that was cross-organization Slack channel. We met our customers in Zoom, of course, and once they say they are onboarding, minutes later, we created a dedicated Slack channel with them, and it works like a magic. There are cases, unusual cases and rare cases, that you can leave the product manager aside. You can leave the business people outside of the loop. Developers understand developers. We have the same language. And now I want to talk about why this project was such a success story. And it is because it has multi-dimensional impacts. For the customer revenue and spend in Taboola increase, of course. And for Taboola, we strengthened our perceptions as an innovative company. Isn't it awesome that the customer has the needs? We translate them into product, but then in the end, they find Taboola as an innovative company. But me and my team, we gained more than that. We had a chance to understand the business better. We met part of our customers, but mainly we went beyond our traditional engineering environment, and it was a great journey for us. And the moral of my story: build an infrastructure that is modular and generic. It will be worthwhile for you later. Make your customer your partner, and find your way to build a direct communication with your customers. It works like a magic. And of course, enjoy your work. Thank you.
I know what you're thinking. Monitoring has a bad reputation. It might seem like a chore, but today I'm going to tell you why I think it's important, what you can gain from it, and how you can implement it in your own team and company. But first thing first, let me introduce myself. I'm Liad. I finished my computer science degree in the IDC. I work at Healthy.io for the past 6 years, currently as a tech lead. And on my free time, I love baking and start the day with some sports. A bit about Healthy.io and what we do. Healthy.io is a healthcare company that turns the smartphone camera into a medical scanner. We have two main product families. The first one is the urine analysis test. It's the same test that you do every other day in the lab, but now you can take it from the comfort of your home. You get the kit home and the app that guides you how to do the test, and you will get results within seconds in the app. By the way, true story, this is my hand in this marketing image. I'm also the hand model of Healthy.io. And yes, before you ask, they are paying for the manicure. I don't think 6 years ago they planned it will last until today, but at that day, as a small startup company with a small budget and only one woman around, they didn't have much choice. The second product is for clinician use, and it enables them to monitor and scan pressure wounds. Using our app, they will be able to get accurate measurements of the wound width, length, and area, and they will be able to monitor the wound progress over time. I am the tech lead of this product, and therefore most of my examples today will be related to this product. So I already explained to you we are dealing with healthcare. You already know monitoring is important, but monitoring in healthcare is even more important. Because we are dealing with sensitive data and patient information, we can't afford doing any mistakes. Also, under healthcare companies, we are under heavy regulation that we need to stand for and provide accurate information. So I'm going to talk today about two aspects of monitoring. The first one is availability, and the second one is performance. I'm going to start with availability. And when I'm saying availability, it's the first thing you should pay attention to when talking about monitoring. Are all my services up and running? Am I ready to get new requests? And if you ever come from the backend domain or the DevOps domain, you probably remember one of those nights, or a couple of them, that you had to wake up in the middle of the night because something was wrong in the system and you needed to fix it now. I'm going to share with you one of those nights in Healthy.io and what we learned from it. Let me introduce the system. As I said before, we are under heavy regulation. It means we have to maintain a UK cluster and US cluster for our UK clients and US clients. So we have both clusters, and in both of them we have both systems, the urine and the wound products. Also under the US, we contain some shared resources. In this example, it's our message broker, which is RabbitMQ. In all of our services, there are health checks in them. They check the availability of the service, and once they detect something fails, they know to automatically go down. So in one of those nights, a Google incident crashed our services, and specifically the RabbitMQ. The wound system in the health check checked the connectivity to the Rabbit and immediately detected it and went offline, while the urine system did not check the connectivity to the Rabbit in their health check and therefore kept serving clients while part of the system is malfunctioning. So we woke up in the middle of the night, we fixed the RabbitMQ, the wound system detected immediately and went back online. We thought everything is okay and we went back to sleep. And only an hour later, we got an alert from the urine system saying a patient could not complete the flow. We woke up again, we debugged it further, and we realized it's connected to the same problem, which is the Rabbit. We restarted urine services, and everything went back online. So two main things that were wrong here. The first thing is we did not get the alert on time. Just because the urine system did not check the connectivity to the Rabbit in their health check, we did not get the alert, and we thought everything is okay in the urine system. The second thing is that once we did get an alert, it wasn't informative enough. It was saying a patient could not complete the flow, and it took us a while to understand that it's connected to the same problem, which is the RabbitMQ. So the morning after, because nothing good ever happens in the middle of the night, we decided we need to create the stability that we need in our monitoring system. And the health check that check only the readiness of the service itself is not enough, and we need to check the system as a whole. So we decided to refactor the entire health checks in the company, such as each health check we'll check the service dependencies as well. It looks like this. If we have a service and it's connected to the database, I'm going to check the connectivity to the database. And if it's connected to the storage to upload some media or more heavy data, I'm going to check the connectivity to the GCS. And if it's connected to a message broker, in this case it's our RabbitMQ, I'm going to check the connectivity to the RabbitMQ. And so on and so forth for all of its dependencies. And this way I will create the stability that I need in my monitoring system, and I will know for sure that when I go to sleep at night, if something failed in my system, I will get alert about it. Now let's move on to performance. And after I validated all my services are up and running, I want to check my system as a whole and see if it's efficient enough. Can I handle load? Will be notified if some service is in a bottleneck or there are too many messages stuck in queue. And once again, we came to the realization that we need a better monitoring when we signed an SLA, which is service level agreement, with one of our biggest partners that basically says that we can deliver results to the customer system in less than 3 minutes. Now, at that time, it was a very high achievable goal, and we were so focused on the algorithm team to build an algorithm that can return results in less than 3 minutes that we neglected the fact that measuring performance is bigger than the algorithm itself. The algorithm is wrapped by an entire architecture of microservices and backend components and message brokers and databases, and anything can go wrong. I drew a simplified version of our architecture. Let's go over it together. The app uploads the wound images and metadata to the client service. The client service then publishes a message to the message broker to the algo runner. The algo runner runs the algorithm, hopefully in less than 3 minutes, and then send the results back to the result service, and the result service trigger another event to the partner service, which is responsible for all communication with the third customer. As you can see, a couple of microservices, a couple of message brokers, anything can go wrong. And what we decided to do to monitor the process as a whole is to add metrics on each service, on each major functionality in the flow with a timestamp. And once we add all these timestamps, we can then sum them all up and get a total time for each flow. So let's see some code, because we are developers, we have to see some code. I don't have much to show you. It's super easy, just one line of code that basically you can add anywhere you want in your code base. In this case, it's in the partner service, and it's measuring the time that it took to the partner service to send the results back to the partner system. And once we add them all up and aggregate them together, we will get this chart of minutes per scan. And we can see that the system is not perfect. There are scans that are taking more than 3 minutes, but at least we can monitor it, we can know about it, and we can do something about it, figure out what went wrong, and fix it. So after I explained you how we improve our monitoring in the past year, now the ball is in your court, and it's your time and responsibility to go ahead and implement it in your own team and company. But before you do, please be aware there are a few challenges. The first one is dev resources. If I didn't invest in monitoring before, so I'm gonna obviously need some dev resources to invest in it now, at least for the first time when I want to build the infrastructure that I need for better monitoring. Obviously, if I'm going to invest some dev resources, I'm going to get a delay in delivery. And it's something your product should be aware of. But don't worry, I'm coming from a product-oriented company. If I can explain the context to my product manager, so could you. The third thing is engaging team members. As I said before, nobody loves monitoring, but we should really explain the context to all stakeholders. For your product manager, I will suggest explaining that customers lose trust very easily. And it's important to get the alert on time, fix it fast before the customer complains. And for your developers, I would explain that on-call routine should not be such a burden. If our monitoring channel is very noisy, we will get more alerts and we will lose development time in context switching. If we don't get any alerts or we ignore most of them, we will potentially lose a problem when it occurs in the system. So let's summarize. There are 3 main points I think you should take home with you. The first thing is separate between the different alerts. Today I talked about 2 aspects of monitoring, availability and performance, but there are more, and each one should be treated differently. Not everything should wake me up at night. The second thing is incorporate monitoring as part of your development lifecycle. If you are adding a new service or a new component to your system, think on how you can add better monitoring to it. The third thing, and the most important one, is just be more proactive with your monitoring system. Understand that you need to do it, invest the time to think on your architecture as a whole and how you can add better monitoring to it, and just do it. Investing in a good monitoring system will help you to build the trust that you need between the customer and the company, and between your developers and their system. And we could all sleep better at night. So thank you and good night. You can reach me out at my LinkedIn or email. Good evening, everyone. I'd like to start with a short video that was my favorite growing up. So, potato chips, you gotta love them. Although that's not what I'm here to talk about today, although they're truly delicious. So this was my favorite TV show growing up, as I said. It shows how products are made, the end-to-end process from the potato to the chip to the store. It's basically a streamline of integrations. Each system's output is the next system's input. If these systems weren't fully integrated, we wouldn't have potato chips, and that would just be sad. So I really loved understanding how things worked when I was small, and until this day, I not only love understanding how they work, but I also love making them work. This is why I'm super passionate about integrations. Luckily for me, I landed in healthcare around 3.5 years ago, where integrations are a big part and challenge of our work. I work at Healthy.io. What we do is turn the medical device, the smartphone camera, into a medical device. Our aim is to get patients out of the lab and into the comfort of their home. In order to do that, we need to make sure that the results are streamlined directly into the health records. So a big part of our product is integrating with healthcare. As we all know, in the past 1.5 years with COVID and everything, it's very, very important to make healthcare accessible to each and every one of us. So I've been at Healthy for 3.5 years. Today I'm a tech lead for our leading commercial product, urine tests at home. Let's look at a few of our partners. So as you can see here, we have a few partners. One of them are Maccabi and Clalit. Pregnant women all around Israel get our kits delivered to their home and do the test. And then the results are transmitted directly into their health records, where the nurse can see the results live and give the patients further guidance. If the results aren't transmitted live, our product is kind of useless, because the patient would just have to go down to the clinic and show the results to the nurse itself. So most of our products are B2B, business to business. However, in the UK, our goal is B2G, business to government. You can see the NHS logo here, the National Health System in the UK. Around a year ago, we landed a very big project with them, which was a huge milestone for our company. And one of its biggest enablers was our mesh integration that we did directly with the NHS. Integrations in healthcare are super challenging. There are a few reasons for that. We'll start with no documentation. When you're starting a new integration, the first thing you want to do is open up the docs and look at the APIs that are available. Sadly, in healthcare, that's not really an option. I'll share a short example. 2 years ago, we started integrating with one of our Israeli partners. We didn't have any kickoff or anything. We just got an email to our mailbox with a text attachment. This was the attachment. What's going on here? This is exactly what we thought. So if you look closely, you can see a patient name and some weight and height. You can make something of it, but it's really hard to understand how to compose something like this. This is why our first instinct was, okay, let's call the person up and ask them what's going on here. Let's ask our technical contacts. This leads me to our second challenge. Sadly, in healthcare, there's usually no one on the other side to talk to. I'm sure you've all tried to contact the governmental institutes in the past, Bituach Leumi, etc. They never answer. They never answer, not even after a week. When you're working on an integration, you need a response now. You need to be working on it and getting responses streamlined. So luckily for us, in the Israeli partner example, we used the geographics to our advantage, and we just went down to their Tel Aviv headquarters, sat with the developers, cracked in until the middle of the night, literally the middle of the night, and we made everything work, our code, their code, and it was a big success. Later on, when we talk about solutions, we'll see that doing the footwork is one of the most powerful tools that is the most efficient. The last thing is outdated tech. As you can all imagine, governmental institutes have old systems that are unmaintained and run old code. This leads to very complicated formats of data that we need to transfer from our servers to theirs. Just as we saw in the last example of our Israeli partners, it was kind of hard. I'll share another short example. This is a mesh message, the same mesh that we talked about regarding the NHS. So again, it's a bunch of letters and digits, very hard to make anything of it. If we look closely, we can see a patient name, we can see some urine results, but it's still hard to understand how to compose it. So when it comes to integrations, we don't have a user manual. I think the best way to learn about how to accomplish an integration is through real-life examples. So don't say I didn't warn you. This is all based on true events. I'd like us to walk through a case study of our mesh integration. This integration was very important to us, and it was very time-consuming. It took us over a year and a half to achieve a working integration end-to-end, and that's what we're going to talk about now. So what is mesh? Well, the first thing that came to my mind is this TV series from the late 80s. My parents used to watch it every evening. And although it's about a field hospital, which is to do with healthcare, it's definitely not this. So what is mesh? Mesh is a messaging protocol. It was written directly by the NHS themselves. And obviously, if you want to be integrated with the government, you better speak their language. Mesh has a mailbox approach. Each entity in the system has a mailbox. The mailbox has a client that is in charge of receiving and sending the messages, and the mesh server serves as the mailman and routes the messages between the different clinics, or in our case, our mailbox, the healthy mailbox. Let's start going through our tools and build together an integration toolbox that at the end of our talk you can take with you home today, and next time you're standing in front of one of these deadly integrations, you can just pop it up and start cracking. So where do we start? Authentication. The first thing you need is an authentication key, something that will give you the access into the system. Usually in modern integrations, you just register, you get an API key, and you can start probing. In healthcare, it's a bit more complicated. As you can all imagine, healthcare systems are barricaded systems that you can't reach. This makes sense because you don't want anybody to be able to access your healthcare information and alter it. It's very sensitive data. So in the case of mesh, we actually need to get a license and register, and it was kind of a long process. The next thing you want is a test environment. You need a playground to start probing the API, sending requests, and see what the response is. In modern integrations, you usually do have a sandbox in order to probe the API. But again, in healthcare, that's usually not the case, and we usually have to test on production, which is another challenge. So we had everything set up. We got our mesh license. We got test patients, we got our client up and running with the messages, sending and receiving, and we could start composing messages. We literally composed tens, if not hundreds, of different messages and tried to get them into the mesh clinic. We couldn't. Nothing was reaching its destination. It was very disappointing, and we were stressed, like, what are we going to do? We have to make this integration work. And also, everybody else has done it, so why can't we? Giving up was not an option. So our next step was doing the footwork. We booked a flight to the UK, me and my boss, and we landed there with a cake. We spent the next few days running around the whole of the UK, trying to find a friendly face in one of the mesh clinics that would help us get into mesh and understand what format we needed to compose. Needless to say, our UK team cashed in all of their favors from the last decade or even more to get us to these people and get us the connection that we need in order to crack in. One of our most fruitful visits, literally fruitful, was to this doctor's clinic in the south of England. We actually ended up going there a couple of times. And around the third time that we got there with a key lime pie in our hands. This was because Linda, the office manager, was really keen on key lime pie, and it was obvious that we would have to bribe her somewhere in order for her to keep on opening the door for us. Another very efficient visit was with Stuart, the IT guy. So we were down in Sussex, we were talking to some doctors, and they couldn't really help us out. At the corner of my eye, I spotted Stuart, the IT guy. We all know that making friends with the IT guy is the first thing you want to do. That's always the best thing to do. So I excused myself politely from the meeting. I creeped up to Stuart. I sweet-talked him to make him like my friend. And I even achieved at the end of this session his private email where I could keep on nudging him from Israel to ask him questions about mesh. It was super helpful. Me and Stuart basically stood in front of a black console and looked at other mesh messages. I asked Stuart, how do other partners do it? Show me how they do it, and then we can reverse engineer and compose our own message to make it go into the system. This was very, very, very helpful, and we were really nearly there. So it was time to go back to Israel. And putting aside integrations for a moment, one of my biggest challenges now was hacking my way back into the house. I left behind in Israel
3 tiny children, and a quite upset partner, and I was just hoping that she didn't change the locks and I could get back home. Well, I got back home, so don't worry, and now we can continue. So we were nearly there, and this was perfect timing to stop and see if maybe there's a better way in. We were so obsessed with getting in that we took the long way in, and we actually realized that there is a direct API from our app to the mesh server that can help us send and receive messages, meaning the client that we set up we didn't really need. And this actually saved us a few weeks in implementation, because we all know that clients are hard to maintain and require more effort. So we were in. Everybody was over the moon. The unachievable was achieved. We were popping open the champagne. The Israeli team was having a party. The UK team was having a party. It was like, okay, time to go to the beach. Nothing more to do here. But we all know there's always a but. Around a month into our working integration, we found out that we had around 80 messages, that means 80 patients' results, that were not received by the clinic. The bad thing was that we were totally blind to the situation and we didn't know that it was happening. The clinic actually called us up and were like, where are the results? We were kind of speechless. So, turns out the mesh system has an ACK system. When you send a message into the mesh server, you get an ACK back saying it got there, and when it gets to the clinic, you also get back a second ACK, 2 ACKs. Now, of course, we knew about these ACKs when we were developing the integration, but we were busy getting in, and we were super psyched about just getting in, and we said, okay, we'll leave the ACKs for later, we'll handle them later. Once we were in and we were able to get back a 200 OK response from the mesh server, we were so pleased. And we're like, okay, it's fine. We'll take care of that later. So no, that was a mistake. We spent the next 2 months trying to understand what was the best way to collect the messages in a reliable way and store them to make sure that we close the loop and that each message got to the clinic and we know that it got to the clinic. You can rest assured, it's 9 months later and we have served over 20,000 patients that have received the results directly to the clinic through the mesh system. So we're up and running and good to go. Let's spend a moment to recap all of the tools that we spoke about today. So we started with authentication and test environment. You need to set up an environment that can help you probe the API and try and understand how to start closing the loop. When you're stuck, going to see the people and doing the footwork is very effective. Turns out integrations are not only integrations between machines, but also integrations between people. The next step is reverse engineering. How does everybody else do it? Always try and peek aside and see if other people know how to do it. And then, when you're nearly done, it's time to look back and see if maybe there's a better, more efficient way in. Last but not least, always, always make sure you close the loop. Thank you, everyone.
Hi, I'm Shir, and this talk is about how we resolved multiple decisions from multiple services using Kafka Streams. I'm here for you to open your mind to new architectural solutions. I'll tell you a bit about myself. I'm a backend developer at heart. I love to design and work on complex software architecture problems. I also love to travel the world. COVID, please go away. And I'm the mother of four-legged Zygmunt and two-legged Leary. For the past 4 years, I have been working at Riskified. Riskified is a B2B company offering e-commerce, fraud, and revenue maximization technology. Our fraud solution is machine learning based and uses behavioral analysis, proxy detection, and more. Our main product is a chargeback guarantee product. We integrate with e-commerce shops so that when a customer is placing an order on their website, the order is sent to us. It can be before or after payment gateway. We then review the order and come up with a decision whether to approve or to decline it. Our main product is a chargeback guarantee product. For quite some time now, we have been facing the challenge of breaking our monolithic code into microservices, which basically means we are working on our system architecture to be comprised of standalone services, each in charge of a specific part. They work together to achieve our system goal, and in this case, return a decision to our merchants. So how does this look behind the scenes? The order goes through multiple services. Each of them can result in a decision. So let's say that service A is the first one to get the order. It then requests a decision from service B, performs some extra logic on its response, and returns a new decision. They can come up with the same decision, but they can also be contradicting decisions. In this example, service B came up with a decision to approve this order, but service A resulted in the decision to decline it. And this leads us to the problem. Each service will persist its decision once finished. Let's take a simplified system in which we have a DB with record per order. We want to have the decision there. When service B has a decision, it persists it. In this case, it's persisting the approved decision to the DB. In that point of time, anyone trying to read the decision from the DB will get the wrong one. Now service A finished and has a decision in hand. It will then need to understand if a decision was already persisted, if it's the same decision or not, and if not, he'll need to revert the previous decision and write its new decision to the DB. So in the case he resulted in a declined decision, he needs to revert the approved and write the declined decision to the DB. This can create concurrency issues, unstable order states, and we might end up with the wrong decision. We had to stop here to think. We thought and thought what would be the best way to handle this situation. We saw in our vision a new service, an aggregator service, which will act as a one place to capture them all and understand the resolved decision. Then we can use that decision and we'll only need to persist it in one place. It will also add the great benefit of separating our persistence code from our online code and prevent multiple services from sharing and accessing the same DB. That goes hand in hand with our microservices architecture vision. So let's go back to those microservices. At the end of the day, they need to share information, events, and data they've come up with. And this is where the concept of event-driven architecture comes into the picture. In this architecture, we use events to trigger and communicate between decoupled services. Your service can publish events, and anyone can subscribe and trigger a process when an event comes in. In Riskified, we use Kafka for that. Kafka is an event streaming platform. It allows you to consume and produce data to any number of systems or real-time applications. All Kafka events are organized into topics. Each event has a key and a value. But what if streaming is not enough? What if we need to process our events? And that's what Kafka Streams is for. Kafka Streams is a client library for stream processing applications. It allows you to create an app that consumes one or more Kafka topics and manipulate your data. For example, you can aggregate your events or join them. And then you can produce calculated values to a new Kafka topic. The topology of the app is where all the magic happens. So how do we take our vision and turn it into our new architecture? As I said, we wanted to come up with a solution that allows us to have in hand all the possible decisions when trying to persist one. And that's where Kafka Streams came to mind. Each service will produce its decision as a Kafka event. Let's say we model our event to contain the order ID as the key and the decision data as the event itself. A new Kafka Streams application will consume all of our services' decision. It will then understand which one is the best decision and produce it on to a new Kafka topic, which contains aggregated decisions per order. A new persister service will then consume this message and will need to persist the decision. Let's dive into our Kafka Streams application and understand what happens inside. So how does this work? Whenever a new order ID is introduced to our Kafka Streams application, a new intermediate object is initialized. It will serve as a placeholder for all of our future aggregations. When a new event is coming in from topic 1, it goes inside the matching aggregator. Matching aggregator means that this aggregator handles the specific message format of events that come from topic 1. The aggregator then takes the decision from the event that came in and fills our placeholder with it. This looks scary, right? But it really isn't. This is basically a wider look on our application. Each time a new event comes in, it goes through its matching aggregator. This aggregator then decides, based on the aggregated decision we have up to this point and the new event that came in, what should be the new aggregated decision. And that's not all he knows how to do. It can actually handle the event regardless of the order they came in. Aggregated decision can be comprised of events from all topics, but can be comprised with less events. At the end, after processing all the events that came from the same topic, from the same key, a final aggregated decision is produced to an output topic. Whenever we'll want to add a new topic into our Kafka Streams application, we will need to write a new aggregator that knows how to handle its input and aggregate it into our aggregated decision. But wait, something is missing. We actually don't want to output an aggregated decision after each event. We need to wait for all the events that belong to a specific order. In that case, we need to add windowing mechanism to our application. So let's look at our Kafka topics, which streams events into our Kafka stream, and place those events on our timeline. All events with the same color are relevant to the same order. So let's say the red ones belong to the same order. That means that we see 3 events that came from all 3 topics, each containing a decision about this order. We implemented windows of 8 seconds that are session-based. Session-based means that each time our app receives an event from a certain order, a new window opens up. He waits for 8 seconds, during which he'll only aggregate the decisions without producing them on. And when he finishes, he will close. Let's look at the red events again. A new window opened after the first event came in. He then waited for 8 seconds and closed. And same for the purple one. Once closed, the aggregated decision relevant to that point of time will be produced to the output topic. So let's remember our desired architecture. We now have our Kafka Streams application ready, and it's writing to an output topic. The output topic contains aggregated decision. All we have left to do is to have a service that consumes events from that topic, and upon arrival of a new decision, will persist that to the DB. It will be the only service in our system persisting decisions. Our new persister service will now persist the decision after at least 8 seconds from the time the order was decided. But we can count on that decision to always be the right one. This matches the eventually consistent principle. If we wait long enough after our order was decided, we will eventually be able to know what the state of the database is, and so anyone that will read from it will get a consistent value. It has to be said, this can hurt our decision availability, and we might need to handle that in other parts of our system. But let's leave that to another talk. So, voila, we've finished building our new system. To sum it all up, we started with a system that has concurrency issues resulting from multiple services trying to persist an order decision. We designed a new architecture for our system and came up with an eventually consistent solution using Kafka Streams, which allows us to persist the best decisions after waiting for all of the other decisions and understanding the best one. Thank you for your time.
Hi everybody, I'm really excited to be here as part of the Women on Stage conference, and today we're going to talk about Java and Kotlin. So a few weeks ago, my friend Jean and I were talking, and she told me that she's got this new project and that she's wondering which language to choose, mainly Java or Kotlin. Now, Jean's group is programming in Java, as did I until about 3 years ago, when I joined Next Insurance and started programming in Kotlin. So I had the background for comparison, but to be honest, the last time I was programming in Java, it was Java 8. And I heard about all the progress that Java had done in the latest versions, so I figured this could be a great opportunity to compare the two and see where they are today. Okay, so hi, I'm Sigal. I'm a software engineer and currently team leader at Next Insurance, and I'm also a developer mom. I consider myself a developer mom, which means my house might be messy, but my code is clean. Okay, so writing code is kind of like riding a bicycle, right? Let's think about a bicycle. What a great invention. It brings you safely and reliably from point A to point B, beats walking, much less maintenance than a horse, cheaper than a car, done its work perfectly. And then sometime later, someone decided it might be a good idea to add a small engine to this bicycle. So now a little bit easier up the hills and a bit more fun. This is kind of how I see Java and Kotlin. They're both JVM languages, only that Kotlin got rid of a lot of boilerplate code and made it a lot of fun to develop and a bit easier to get to the endpoint. Okay, what are we going to talk about today? We're going to talk about 3 main topics about null safety, type inference, and data classes. And at the end, we'll briefly go over comparison of features and where they are in Java and in Kotlin today. Okay, nullability. The ticking time bomb of null pointer exception, which is probably one of the major causes for runtime crashes. A big headache for Java developers. What can we do about it? So in Java, every object might be null. This means that every time we want to approach a variable or a method of an object, we first have to make sure that it's not null. Otherwise, it will result with null pointer exception. So let's think of an object that contains other objects. How can we avoid null pointer exceptions? So till recently in Java, what did we do? What do we do today? We need to check that it's not null. So every time we go one level deeper, we need to verify that the upper object is not null. Java 8 introduced us to optional, kind of Java's way to add some null safety to the code. What is optional? Optional is sort of a single value container, so it can contain a value or not, and it also adds methods to help us manage and handle this situation where we have or doesn't have value in the optional. This way, we have to keep in mind that the value may or may not exist. So with using the method of the optional, it forces us to think about nullability and helps us avoid null pointer exception. Let's take a look at some examples. So this is how we initialize optional. We can initialize it to be empty, which is like our equivalent to null. We can initialize it to a nullable value, or we can use off and make sure that the value is not null. If it is null, we will result with the null pointer exception. How do we use it? We can use the if present to run something only if the optional has value. We can use the is present to check if there is a value or not, and maybe only that get the value or do anything. And we also handle, we also have ways to handle empty values, similar to null. So what do? We can assign a default value, or we can decide to throw some sort of exception if there is no value. What do we have in Kotlin? So we have few things in Kotlin. First, we need to know that a variable in Kotlin can be defined as nullable or as not nullable. This is done using the question mark. So if a variable has a data type that if we add a question mark after the data type, this means the value is nullable. if we omit the question mark, this means this value cannot hold null. And we can be sure for the entire lifetime of this variable that it will never hold null. And we will never, well, we will get null pointer exception if we try to assign null to it, but it can never be null. One more thing is that the null safety is added. Kotlin is, as we said, is a JVM language, so the null safety is being added to the compiler bytecode. So we don't need to see it in the code, but it's being done behind the scene. Another thing that we have is the safe calls. This means run it only if the object is not null. So this is Kotlin's way to avoid null pointer exception. So if in Java we would call it using only the dot and we would fail, then here we won't fail, it will just return null. So let's see an example. So if we use here a nested object and calling it along the way, it will return the value as it should, or it will return null if somewhere along the way the object was null and no null pointer exception. Another operator is the double exclamation mark. This is used to convert a nullable variable to a non-null variable. So this should be used with caution. Here's an example. If I use it on a non-nullable object, everything is fine. It will convert to a non-nullable. If the variable was null, it will result with null pointer exception. So you need to really be sure that the value, there is a value and it's not null. And last but not least, the Elvis operator. One of the nicest one. What it means is assign a value if null. It's kind of having or defining a default value in case the value is null. If you're wondering why it's called the Elvis operator, it's because the question mark in a column kind of looks like Elvis's hairstyle, or if you don't believe me, I've prepared this. Okay, so this is how it's used. If the left-hand side of this operator is not null, it will return it. If it's null, it will return the right-hand side. Okay, next, type inference. How is type inference being used, or what's its status in Java and in Kotlin? Let's have a brief look. So what is type inference? Type inference is the ability to detect the type of a variable, for example, without having to explicitly define it. In Java, as we know, is strongly typed. We need to define the type of a variable, of a return type of a method, the arguments. We usually define the type. We will see later a little progress. Kotlin, as we said, also compiles to Java bytecode. So obviously it is also strongly typed. But we do use var and val. We don't have to define the type. Kotlin can understand the type. The compiler can understand the type using compile time and just adds it behind, so the code is cleaner. Here's an example. If we have value x and it's assigned a string value, then Kotlin will understand that it's a string. Or if we need to, or if we like to, we can obviously define the type explicitly like that. In Kotlin, we have two types of variables. We have a mutable variable and an immutable variable, which can be initialized only once, similar to final. So to define a readable, let's call it, variable, we use the val keyword, kind of like a final in Java. Otherwise, we use var. Okay, so here's the difference. A val can be initialized only once. The second time will result in compile time error. And val can be changed and reassigned as many times as we like. And we also have inference in methods. We don't have to define the type of the output of the method. It can be understood using the expression. Okay, Java 10 did introduce us to var, did a major step towards type inference. So we have the var, similar to Kotlin, but different. Let's see the differences. So main differences are. First, as we said in Kotlin, we use var for mutable and val for immutable, where in Java it can be either mutable or immutable. You can add the final and make it immutable. We can, in Kotlin, we can use it anywhere we like. In Java, it has to be, it can be only used for local, like local members of a method. And in Java, it has to be initialized on the spot. In Kotlin, we can initialize it later, but then at the declaration part, we have to define the type. Otherwise, the compiler won't know which type to give it. OK, let's go ahead and talk about data classes. What are data classes? Data classes are sort of like data containers or data carriers. They're objects that all they aim to do is hold some data. So kind of like when we take a result set from the database and we only need to keep the data somewhere. I'm sure you have tons of examples of where you use simple, very simple classes that only hold some data. So let's think about the class person. It has 3 variables. It has first name, last name, and an ID. How will it look in Java? So we need to define constructor, equals toString, hash code, getters, setters. This is not even the entire class. A lot of boilerplate code, a lot of things that could be generated automatically. We have to define a lot of code. Kotlin introduced us to the data class, which using this notation, if we use data class to define for a class, all we need to do is define the members of this class, and all the boilerplate code, all the equals, hash code, toString, everything will be just generated behind the scene automatically. OK, Java 14 introduced us to a very similar thing, the record. You can use, it was introduced as a feature in Java 14. It was finalized in Java 16. Very similar, one-liner to define a class, just define the members, and it will define all the very obvious code automatically. Let's see some differences and similarities. So both generates equals hash code toString constructor. Kotlin also gives us the copy method, which enables us to copy one data class to another and only change few of the members. Immutability, which is a big difference in my opinion. Records are completely immutable. All the fields are private and static. Private and final. In Kotlin, you can define some of the members as var, so they can be changed later. And also, Kotlin gives us the option to add secondary fields. They will not be part of the equals hash code toString, but we can use them in the data class. OK, let's do some comparison. I've made this short list of features. Let's go over it very briefly, because we don't have much time. So what we have here, we talked about nullability, we talked about data classes. Kotlin also gives us coroutines, out-of-the-box implementation for lazy initialization and singleton, and implicit inline functions. Switch and sealed classes were added to Java later on as a progress in the immutable collections area, and type inference, which we've discussed. Kotlin also added us a very cool feature called extended functions, named parameters and default values, which can come very handy. Got rid of the new semicolon checked exceptions. No more of those in Kotlin, and some better string management, which was also improved in Java. So finally, which should Jean choose? So Kotlin is the new cool language with a lot of features, and Java is the senior one, but it's not left behind and adding a lot of capabilities and a lot of improvements. Personally, I have a warm place in my heart for Java, but Kotlin is truly awesome, and it's definitely my favorite. And thank you.
Hi, welcome to my talk. Find me if you can, how to locate DLL's unexported functions. I'm Oriane de Paz. I really love Windows internals, reverse engineering, and generally learning new things. On my day-to-day job, I work as a low-level researcher and developer at Symantec. So usually, I'm in charge on detecting malwares, but today I'm on the hacker side. And today, so are you. So let's say that we want to take over the world. And in order to do so, we want to run our own code on a remote process. So when we want to run our code on a remote process, we need to load our code into its memory. A legitimate process will usually use the WinAPI function. Will ask the remote process to call to the WinAPI function a load library. A malicious process can do the same. But since this function is monitored by antiviruses and registered into internal structures of the operating systems, it can raise an alert. And we don't want this to happen. So that's not a really good option. Instead, we can write our own loader, which will be implemented pretty much like the original function, but we'll skip the parts that we want to skip. This technique is called reflective loader. And in order to implement it, we will need to use the internal functions that the original function uses. One of these functions is LDRP and LTLS data, and this would be our target function for today. And it's important to understand that we don't really have to understand what this function does at this moment. All we have to know is that we need this function, we need to use this function, so we have to look for it. And why is it so hard to find it anyway? So, well, we can use exported functions both statically importing its DLL and call it from our code, or dynamically using the WinAPI function getProcAddress. With unexported functions, we can't. So why is that? And actually, every module has a table that maps some of its function's name to their addresses in memory. And unexported functions are all the functions that don't appear in this table. So we have to find them ourselves. So today we're going to cover 3 different ways to locate our target functions. Then we will compare their stability on different OS versions. And finally, we'll choose our favorite way to use. Our first way to locate this function would be to find a unique byte sequence inside our target function. So this is part of the code of our target function. And this is the disassembled function taken from the compiled binary using the IDA disassembler. And it consists of 2 parts. There is the instruction of the code, and there's the actual byte representation in memory. Now let's take a look at these 2 lines of code and their byte sequence. This byte sequence is unique, and it appears only once in the entire module. So we can use it, we can search it for it in memory. And then once we find it, all we have to do is decrease its offset to the start address of the function. So our formula would be the byte sequence address minus the offset. So let's say that the byte sequence address would be this address, and its offset would be 46 in hexa. So our target function would be in this address. our second way to find this function would be to locate a direct function call using a unit byte sequence. So this is the function who calls our target function, and this is the actual call instruction to our function. And this call instruction also consists out of two different parts. There is the actual call opcode, which is represented by E8, and it's followed by the offset of the function that we're of the target function, which is relative to the end of this call instruction. Now let's take a look at these few lines of code, and these are the preparation for passing the parameters to the function. And generally speaking, it should be more stable to use their byte sequence instead of locating a random byte sequence, because this one depends on the function signature, and this one is less likely to be changed. So we can search for this byte sequence in memory. Of course, it also has to be unique. And then all we have to do is to add the offset that we found that follows it. So this time, our formula would be the byte sequence address plus the byte sequence length and the offset that we found. So let's say that this time our byte sequence address would be this address, and the byte sequence length would be 11 bytes. And then we have to add 4 more bytes because this is the offset length, and as we mentioned before, the offset is relative to the end of the call instruction. So our total length is 15. And then all that's have to do is to add the offset that we found, which is 47. So we'll find this address in memory, which is exactly the same address that we found before. So we have 2 different ways to locate the same address in memory, which is pretty cool. Our last way to locate this function in memory would be to locate an indirect function call. And what does it mean? So let's take a look again at the function that calls our target function. And if so far we focused on the byte representation, now let's focus on the actual instruction. So let's zoom out for a second, and we have this function, our target function, which we already mentioned that it's internal. And we have the function that calls it, right? So what if this function that calls it is also internal, and the function that calls it, and the function that calls it, and the function that calls it, and so on until we get to our exported function. And of course, let's not forget that the function that calls our target function can also call other functions as well. So back to our code. And this time, I want us to focus on the fuller view of this function. And we can see here that it has 5 function calls inside. And our function is the second function that's being called. So if we'll step into the offset that we found in the second call in this function, we will get to our target function, right? But remember this picture? Well, we found a way to find our target function, but how can we find the function that calls it, and the function that calls her, and so on and so on? So the answer is exactly the same. Now let's take a look at the calls flow. And this is the functions, this is our exported function in our case, LDR load DLL. If we'll step into the second call out of the 8 calls in this function, we'll get to the function LDR pload DLL. Then, if we'll step to the third call, we'll get to this function. Then we'll step into the 5th call out of 21 function calls, which it tells us that this function is probably bigger. Then we'll step into the first call, then to the 6th call, and eventually, like we previously saw, the second call from there will give us our target function. Once we found the function address in either one of these ways, we can simply use it in our code by calling it from our code, and it's that simple. Now, okay, so now let's talk about the stability on different OS versions. And the first method that we saw was to search for a unique byte sequence inside our target function. And actually, this turned out to be the most stable way. We covered all Windows 10 versions through only 2 unique byte sequences, which is pretty cool. Then we have the direct function call. And this turned out to be the most unstable version way to find the function in this case. We had more than 4 or 5 different byte sequences, so it's less likely for us to use this method in this case. And the last option was to find the exported function and then step into the inner calls until we get to our target function. And actually, in this case, we saw some functions that might be too complex in this particular flow. But it still had 2 main options through all Windows 10 versions. And the functions were called relatively at the beginning of the functions. So we could rely on this. If the function had too much calls or the amount of calls would change too often between the Windows versions, then we couldn't rely on this method. But the most important part to say here is that it can change between different functions. So there isn't a right or wrong way. All of these 3 ways works, but you have to choose what's better fitted for your specific function that you're looking for. Now we have 3 different ways to find our function. We can successfully run our code on the remote process. And that's it. For any further question, you can find me on Twitter. This is my Twitter handle. And thank you for listening.
Hi everyone, welcome to my lecture, Community is Everything, which basically gives you a tease on how useful are graph analytics. A little bit about myself before we start. My name is Lior. I've been a data scientist for the past 6 years, and in the past... A little bit about myself before we start. My name is Lior. I've been a data scientist for the last 6 years, and in the past 3 years, I'm also a team lead at Riskified. When I'm not working, I enjoy traveling, solving all kinds of puzzles, as you can see, and my favorite hobby for the past year has been Netflix binge watching. Hope I'm not alone here. So today we're talking about graph analytics, and in order to show you some of its cool features, I use a business need we had at Riskified. Riskified helps retailers deal with any kind of problem they face through the customer journey. Whether it's at account creation, login, checkout, or anywhere in the flow, we come to help. At some point in time, not so long ago, we started hearing merchants describe a new problem we call policy abuse. I'll explain policy abuse with an analogy we can all relate to. This is a wonderful time to be a private consumer. When you want to make a purchase, we have various vendors to choose from. We can decide where to shop based on location and brand reputation and price, shipping time, so on. So, great for us. For vendors, on the other hand, not so good. These vendors want to do everything they can, so we choose their shop. And they have a lot of competition going around now. What most of them do in order to attract us in is to offer many kinds of benefits for their customers. So, what's the problem with that? It sounds fantastic for everyone. We get choices, the merchants give out benefits, but they get loyal customers in return. Where's the catch? So here are a few examples. One of the benefits merchants offer in order to attract new customers is a discount on their first order. Notice how they say here, new customers only, and that codes will be sent to your email address. Well, I have to wonder whether a new email address really equals a new customer. I mean, we all know a new email can be generated in a matter of minutes, so we all understand the secret here. Most people are legitimate shoppers. They use the discount once. But some people think, why don't I just use this 20% off all of my purchases? And they go ahead and create new emails with fake details and new accounts and get their discount codes over and over again. Another really popular example is referral programs. We all know how it works. You refer your friends, they get something, you get something. Everyone's happy. Unless instead of referring your friends, you refer your fake accounts and accumulate the net credit over and over and over again. One last example is the most sophisticated use case we've seen so far, and that is when a sneaker merchant has a limited quantity of popular pairs of shoes, and they offer their loyal customers a chance to each get one pair. In many cases we've seen, bots who generate new accounts can end what is supposed to be a 24-hour celebration in a matter of minutes. So I hope the problem is clear by now. We have an order, and we need to figure out who's behind that event, and if we've ever seen them before. The question we ask is, are they really new to us? Let's see what do we have to work with. The first piece of the puzzle is data elements. Every order we collect has many elements as data points. For example, if I place an order and I try to use a promo code, I enter my email address, my billing, shipping details, phone, credit card, and so on. On top of that, Riskified collects additional data, and these combined are the elements we can work with. So, as I just mentioned, elements are data points of orders. On top of orders, there are accounts. An account can have 0 to n orders, and each order can have different data elements. These elements are what we're going to refer to later on as edges. The accounts are what we'll refer to as nodes. Let's talk about some relevant graph terms. Graphs are essentially networks of a partially or fully connected objects. You can think of a social network as an example. The objects are people, like you and I, and the definition of connection between us is whether we are Facebook friends, we follow each other on Twitter, Instagram, and so on. Nodes in a graph are the objects, you and I. An edge is what defines a connection between those objects or nodes. If we stick with our previous example, an edge will be drawn between you and I if we are Facebook friends. A component in graph theory is a subset of a graph in which any two nodes are connected to each other by edges. In our example, we can see we have one component connecting nodes A, B, and D. Node C is also a component of size 1. It only has one member, and that is node C. To emphasize, if we were to break this connection between nodes A and B, we would end up with 3 components. Now that we all know these graph terms, I'm sure you ask yourself, well, what can I do with these? Here are a few examples of analyses we can perform on graphs. The first type is path analysis, which is the examination of relationships between nodes in a graph. In other words, it determines the distance between a pair of nodes. So this is a measure of proximity in a network. We can also use connectivity. The connectivity of a graph is an important measure of its resilience as a network. It asks for the minimum number of elements, either nodes or edges, that need to be removed to separate the network into isolated subgraphs. You can think of a network describing a virus spread and how crucial is connectivity in that case, right? We want to stop a spread, we need to understand exactly which ties to break in order to make that happen. Last, at least for today, we have centrality. Centrality analysis enables us to estimate how important a node is for the connectivity of a network. For example, it can be used to determine the most influential people in a social network or find the most accessed web pages. Let's turn back to our data and remind ourselves how it looks like. So this is what we have in a tabular form. That's the essence of how transactions look like. I've obviously left a lot of details out, but this gives you enough of a view to work with. Now let's take everything we've learned and put this all in a graph. And this is how it looks like when modeled into a graph. Now, we're quickly able to make some assertions about our data. We can see how connected or isolated are our nodes using the edges we've just defined. We can calculate the shortest path from one node to another and extract which nodes are centralized. And actually, this looks much more informative than the tabular view we've just seen. And after all, why is this still not enough? In large graphs, especially those who are around textual elements in the context of multiple data points, there's a tendency for many nodes to become connected and create giant components. In order to separate these densely connected networks into smaller, cohesive entities, it makes sense to use community detection to help. When analyzing graph networks, it could be important to discover communities inside them. If you think of a social network, for example, it could be helpful to find people with similar interests and keep them tightly connected, so we can show them the same ads, suggest the same groups, events, and so on. In general, community detection algorithms can be used to detect groups with similar properties. If that rings a bell and reminds you the problem I initially introduced, you got it. This is exactly what we want to use in order to find groups with similar attributes and classify them as the same entity. And then we can say, hey buddy, seems like you've used this promo code before. Sadly, we cannot allow you to redeem it once more. So now, one of the components we had before is split to 2. Community algorithms basically split nodes into groups of size 1 to n. How does the split happen? Well, there are multiple algorithms and each has its own metric to help decide on a node's group. In the essence of time, I'll briefly explain the logic behind the most popular optimization measure called modularity. Modularity is a scale value between -0.5 and 1 that measures the relative density of edges inside communities with respect to edges outside communities. In simple words, if we optimize for modularity, the communities we generate will indicate which nodes are more densely connected between each other than to the rest of the network. Optimizing this value theoretically results in the best possible grouping of nodes in a given network. Now, I found a cool example taken from a Git repository called Communities that show this in action. So we start with every node in its own group, and we see there are edges between many nodes to others. Now, a heuristic algorithm groups nodes together until it finds the optimal group for each. And at that point, modularity is the closest it can be to 1. So when we at Riskified see accounts popping up in our system, we try to match them to their relevant community. They are no longer separate entities, but a tightly connected groups of nodes, which we can now apply all kinds of machine learning techniques on. To conclude, we had a business need, solving the problem of customers abusing benefits offered by the merchant while disguising as new customers. We used the strength of graphs to help us solve this problem and identify hidden similarities between seemingly unrelated accounts. And this is just one example of how graphs are useful. If I had to offer you one thing following this talk, it would be that you look for a problem within your day-to-day task that fits this type of modeling, and go ahead and explore it yourself. I hope I helped you figure out it's more intuitive than you imagine. Thank you for your time. For any comments or questions, feel free to reach out over social media.
Today, you're going to see how you can debug your app with a single tap. But first, I want to share with you how a day of my life as an iOS developer looks like. Our app at Healthy.io enables people to perform a urine test at home. For example, the app you can see now, Kidney Check, enables people to perform a kidney test straight from the comfort of their home. In the beginning of the app, our lovely nurse Emily gives instructions to the user to know what he needs to do to perform the test. When the instructions are being done, then it's time to perform the test. As you can see, the user uses the camera to scan the test and then is being transferred to the processing screen. In the processing screen, we're verifying that we have everything that we need, that we succeeded to collect everything, the scan was correct, and that we are able to provide results to that user. When we finalize and we get the results, we notify the user the results are ready, and he can review them in the results screen. Our product came to me one day and requested a new feature. He wanted that the text below the what's next line that you see here will give a bit more information about the results that the user received. What does it mean? It means that if we got a normal, then the user will know exactly what it means and what the following steps that he needs to do. This is not a problem, so of course I did it quite quickly, and now it's time to actually see that what I did is correct. You saw that the user needed to do a lot of steps to reach this specific screen. Unfortunately, this is what I needed to do as well. On my first take, I had a problem with my scanning and with my test, and I received an algorithm error. I couldn't continue on, and I needed to start all over again. After some takes, on take number 5, I wanted to start the app, but unfortunately, I received a connectivity issue. That means that the server was down. Apparently, they're doing some maintenance in our testing environment, and I couldn't continue. Then I needed to start all over again. Unfortunately, this happened to me quite a lot. Hi, I'm Yuval. I'm an iOS developer at Healthy.io. I have a bachelor degree in computer and cognitive science, and I lived in Amsterdam for 2 years and as an Israeli delegate of the Jewish Agency, and I fell in love with gyrotonic. If you don't know what it is, you should look it up. But really, I love baking, but in the beginning, I was not that good. I thought that I could follow the steps correctly. You know, putting some flour, some baking powder, whisking some eggs. But one time, just before putting the cake into the oven, I realized that instead of half a cup of sugar, I put half a cup of salt. Turn off the oven, there is no cake, and of course, I needed to start all over again. This experience reminded me of the same experience that I have while testing my app. Every time that I needed to start my app from the beginning, it was because of that salt in my cake. You probably can think to yourself, okay, what is really the problem? It is your code. You can change it locally. You can do some comments or delete the code and skip all the first screen to reach the results screen, what we needed to go to. You can think of it as like going to the supermarket and buying a prepared mixed cake. You skip the first steps, you whisk it up and put it to the oven. But I'm here to tell you why this is not a good enough solution for us. First of all, there is a risk of reaching production. With one moment that you don't look or you lost your concentration, the code will be committed and reach live users, and they will have the same shortcut that you just did for yourself. Not every flow or scenario is easy to create. It can be really hard to simulate that specific scenario. And once you did it, it's really hard to maintain it. Where do you keep the code? This code is relevant only for that specific time. Tomorrow your code is changed and you need to change it as well. It doesn't really simulate a real flow. You know, when you're buying a prepared cake mix, it doesn't really taste like a homemade cake. The changes are being done only locally on your computer. What about your teammates? Maybe your QA can use it as well. It doesn't really scale. And of course, it takes a lot of time. From a feature that took only half an hour, I can spend double or triple of the time trying to reach this screen in a shortcut. So we saw that it's risky, it's complicated, it's not real. The changes are being done only locally, and it can take a lot of time. This is a lot of effort. Probably there is a better way that we can do it. And I'm here to tell you that there is. We, with a single tab, can reach every flow or scenario within our app. And we're doing it using our debug screen. So here is our debug screen. You can see live how with a single tab, I can reach the same screen that I wanted to reach before, but this time I don't need to go through the full flow. I don't depend on the server, not the algorithm, just on the clicks that I do with my finger. So let's see what it is. So this is our debug screen. Each row represents a different flow or scenario within our app. It is important for me to tell you now that this is available only when I compile my app on debug environment, meaning when I deploy this app to the store and reach actual users, they will never have this access to this screen. So okay, we know that we need to have the flows or the scenarios, and we wanted to keep the responsibility away, the responsibility separated from the view and what keeps the logic. Meaning that my representing view will concentrate only on navigation and representing the screens and the scenarios that I need to present right now. So okay, I need to have sort of a data source, but what it will contain. I know how to initialize any flow or any scenario in my app, but it can look very messy and it will be really hard to maintain. And every scenario can be a bit different. And then, okay, my view will need to know everything. It sounds really complicated, and it brings us back to the same problems that we saw before. We thought, okay, we need to approach it a bit differently. So we created a debug item provider, which contains different items. An item is an abstraction, a wrapper above the object that I want now to present. This allows me to separate the logic between the representing view. So let's see what it is. So this is our debug item. This is the wrapper. You can see it's a very simple struct that has only two parameters, a title and the action. The action is really the heart of the item. This is what defines the item and it defines which object it's wrapping. Each item can confirm only one case, meaning that if I have now a result item, it will be able to confirm only one specific case. So our action is a function that actually creates that specific object that I want now to present. You can pass here some dependencies. It all depends on your implementation. This is possible only because we succeeded to separate our full flow to small sections or mini flows, and I can detach them from the main flow, meaning that if I want now to reach a section of the flow in the end of the flow, I don't really have to go through the full flow to initiate it. I can just take this section and play around with it and initiate it whenever and wherever I want. It required a bit of refactoring in our code, but it was worth it. So let's focus a bit what is a case. As I said, a case defines the item. The case makes a difference between the different flows and scenarios within our app. This is also a contract between the item and the representing view. Me as a representing view, if I have now an item with that specific case, I know when I'm running the action that the returning value that I will receive will coordinating with the case type, which means that I will be promised to receive that specific object that I need to show now. For example, we saw in the beginning that we have a lot of screens. A screen in iOS equivalent to a UI view controller. So of course we need a case that will represent this type of scenario or this type of flow. So we have a VC type that when running the action, it will return a UI view controller. You can see here also that I didn't write a results view controller or processing view controller. We are returning a UI view controller, a general thing. Because for me as a representing view, I don't really care which UI view controller I'm now presenting. I just care that I'm presenting a UI view controller, and I know now what I need to do with it. There are more cases that you create depending on your app, and later on we will see a really cool case that we added to our flow. So now that we know the definition of an item, let's take a closer look on an example implementation. So we will we will focus on the results screen. Okay, you can see here that we have 4 different items. Each item is coordinated with a value, a specific value of the results. This is possible to do because we were using a dependencies injection. The results screen is not responsible on getting the results itself, but he is relying on the object that creates this result screen to give him the results that he now needs to present. This allows us the flexibility and the way that we can simulate any scenario that we want. So let's take a closer look on the implementation of the negative item. So as you can see here, we have an array of result items. I will show you now just the negative one. We said that the action is the heart and the result screen is a UI view controller. So of course I'm using the VC type case, and as you can see in the end of the function I am returning a view controller. I wanted it to be negative results. So first I create a mock exam results and then I inject it to my results view controller. Now all the logic is being done, and when I am the representing view receiving this item and running the action, I do not need to know all the small detail, all the specific logic details that connected me to that specific object. I will just get back the UI view controller and I will know how to present it. This is really cool. Already now we have a really cool tool that allows us to navigate through the app quite easily. But in real life, we are depending a lot of the times on dynamic data, and mostly it's received by the server. We were thinking, okay, maybe we can do something cool and incorporate the network to our debug screen. This is when our async item was created. So as you can see here, I didn't need to define again what is an item. I didn't need to change anything about my wrapper. I just needed to add a new case to my action. What does it mean? It means that I can save the structure of our debug screen. I don't need to change much. I just need to add a new case, and that the representative view will know this specific case and what to do with it. I'm passing a network handler. So in the action, this will be used to perform the network call. And I'm also giving a callback, what to do when the network call was done. But you can see here, opposite to what we saw before, that it looks like we're not really fulfilling our contract. As I said before, our contract was that when I'm running this specific case, I know exactly which type I'm getting in return when running the action. But here, as you can see, there is no match. But let me assure you, the contract is being fulfilled, but just in a different way. Because this is a network call, we cannot really promise that this item will be created. The network call can fail for many reasons, and then we don't have an item. This is why we're going to receive that specific item through the callback. In case of a successful network call, if I succeeded to receive the data that I need and created the object that I want now to return, I will send it back, as you can see here, on the result in case of a success. I will return a UI view controller. Otherwise, I will return an error. Why this is important? Because this time the user is me. And for me, it's really important to know why exactly this network call didn't succeed. Now it's a piece of cake, right? Not only that it helped us, the developers, but it helped also other domains in our team. Our product, QA, and our designer are using this tool on a daily basis, and it makes their life even better. So we saw that we have the debug screen that really took a lot of the effort of the testing and debugging our app, and now we can navigate through our app very easily and quickly with just a single tab. Now it is time for you to debug your app with a single tap. Thank you very much for listening. You can reach me on LinkedIn or by email. Feel free to ask me any questions, and of course, give me some suggestions to my debug screen. Thank you and good night.
Hi everyone. I'm going to talk about building an SDK that developers will love. So first of all, what is an SDK? SDK is initials for Software Development Kit. It's a set of tools that can be used to create and develop applications. In other words, everything a developer needs for a specific feature. An SDK refers to a full software module that includes everything developer needs for a specific feature within an app. So a little bit about myself. I am Zufit Lifshitz. I have 8 years of experience in software development. Over the past 4 years, I've been working at Taboola on the SDK that runs on thousands of devices. And also, I like making uncomplex from complex. As I said, in the past 4 years, I've been working on the SDK. This includes also working with clients that use the SDK and learning from them which parts cause difficulties in the integration. I had to see that all kinds of developers on any level are able to implement the SDK. I followed the implementation of the clients and saw that there are too many steps and things they need to remember during the implementation of the code, which caused a lot of mistakes and misses. By mistaken or missing one part, the component the client is trying to create with the SDK won't work, and sometimes even the application of the client can crash or not work well. And those can also hurt many of the business models of the application that is based on the SDK. And that's why when building the SDK, we need to make sure all of the steps are clear. So after I worked with the clients and learned how to make the implementation of the SDK easier, I want to show you some of the changes I made in the SDK. Every one of you can adapt some of the things in your code or create your own amazing SDK. You can take these points to any code you write or build an internal library in your company. The first thing I saw is that there are too many functions and variables that needs to be initialized, which is confusing for the developer. Have you found yourself in situations where you use someone else's code and it's not clear where to start and which function to use? It can be code by a developer who worked or works with you in the team, or when you use an SDK. What happens is, when you write an SDK or framework, you want to allow as much ability and flexibility as possible, which leads you to open up many possibilities in the process of creating a particular component. In practice, this causes a developer who uses the SDK to have too many ways of implementation and has no way to know what is mandatory and what is not. This increases significantly the chances of creating serious bugs. So let's start with an example of code to see how the code looks when you want to have a lot of possibilities and flexibility and what happens because of it. And in the end, how to fix it. This is an example of using the SDK to create a view. The view is called coolView. We can see here that we are setting a lot of properties and we don't know if we need to set all of them. What will happen if I miss one of the properties? Will the view be presented and work? If I set only the number of items, is it enough to show the view? Or maybe I also need to add the name and the size. This is very confusing, and the developer has no way to understand which property is mandatory. To fix it, what needs to be done is to create one direction. In the process of planning the SDK, we need to decide and understand what are the steps that have to be done to make the feature work. Which of the properties are mandatory and must be set by the developer that uses the SDK, and which of the properties we can set by default inside of the SDK. And give them an optional function that the developer can decide if he wants to use. Or in simple words, we need with few lines to first have something working as fast as possible and as simple as possible. And only then let the developer change the behavior according to to the customization he wants. Let's take the long example we just saw and change it to this. We can see here we are creating the cool view only with one line and only with the mandatory properties in the constructor. The rest of the properties that are missing here and we saw before are set with default values inside of the SDK. This makes the implementation much easier and with only 2 steps. And if the developer wants to change the default behavior, he can set the properties. You can see here that he sets the color, the size, and the is lazy load, but all of them are optional. But even by setting the properties only in the constructor, the developer will get a view that is presented and working simple and fast. In some cases, the developer will want to use the SDK to create multiple components. For this example, we want to create multiple views and add them to the main view. These views need to communicate with one another and be presented according to the previous one. We can see here in this example that we first create one cool view and call the function load. But we need to wait for the completion of the load to create the second view. This is because we need to synchronize between the loading of the 2 views. So after the first view was loaded, we created and loaded the next view. This can be too complicated for the developer, and he needs to remember he can create the next view only after the first one was completed. Let's look at how to make it easier. We need to create an object that will have control and manage all of the cool views in the page and synchronize between them. You can see in the example, we created the page view object manager and initialized it with number of cool views in the view. And from the page view object, we create our cool views with the same properties like before. And in the end, just call once the function load, with no need to remember anything and synchronize between the 2 cool views. If you go back to how we started, with multi of function and properties that needs to be initialized and synchronized between the views, this is how the code will look without the changes. And this is the code we have after the changes. Much more easy, short, and clear. So let's summarize. We always need to remember that our client, the developer in this case, has to approach the task of implementing the SDK without having to fight with the code and not understanding how to implement it. So our job is to make sure the implementation is as quick and easily as possible, without too many places to get confused. This seems trivial, but in practice, a lot of libraries and SDK try to allow as many possibilities as possible, which creates situation where implementing the SDK requires expertise and can cause a significant increase in creating bugs. The most important thing is to know how to separate the mandatory part from the rest, to allow the implementation to be as quickly as possible and work smoothly and without problems. And only after, we will add an option to make the adoptions that specific developer wants. In any SDK or library that requires synchronizing between several components, we want to take all of the control inside of the SDK, because we are the one that knows the behavior of a product, and we have a deeper understanding of how everything needs to work. The last point to consider is that many times in the specification and design review phase, we focus on design that we think that's right for us developers. Modularity, scalability, efficiency, etc. But do we at this point also focus on design that allows the developer that uses the SDK to work more easily and intuitively? It may be that in product like SDK, it's worthwhile to sacrifice software design in a favor of design that will allow the developer to use the SDK in a more intuitive and clear way. From my experience, the more you stick to these principles, the more it will serve you in the future and save you customer support. So thank you, everyone. I hope you learned new things. If you have more questions and thoughts, you can send me an email to tsufitleaf@gmail.com. Bye, everyone.
Wow, what a fabulous first day covering backend, security, and mobile. So many beautiful sessions, so many inspiring women. Thanks again to all of our amazing sponsors. We truly couldn't have done this without you. All of these companies are companies that actively support diversity as part of their agenda. Thank you for being part of the change and helping us to make these incredible voices, to make sure these incredible voices are heard. Thanks to all of our speakers, our keynote speakers, event handler for producing the event, and to all of our course mentors and instructors. Be sure to follow us on social media, invite our speakers to speak at your next event, register as a speaker on our platform yourself, or register to our next round of the Speakers Academy. My name is Moran Weber, and on behalf of me and Women on Stage, we really hope you enjoyed yourself, and we're looking forward to seeing you tomorrow on our second day. Thank you.